This has not appeared before. This has not appeared ever in past paper questions. So I've made this question up. What is the process which are going to enable us draw any diagram question? After reviewing multiple past papers, I have selected 7 questions from chapter 1. So these are my selected chapter-wise questions. Chapter 1, which means the data representation chapter from paper 1. And we have selected chapter-wise questions from 2018 to 2025. So after reviewing multiple past papers, I have selected 7 questions and 1 draw question. Now this is interesting because draw question from chapter 1 has not appeared before. But so the idea behind draw question is not that you must memorize the question that has already appeared, but it is to practice the ability to visualize any theoretical concept. So this is a new and unseen, unappeared question, but it will give you the idea how to draw any given draw questions instead of memorizing it. Thirdly, in some questions I'm going to apply the backtrack method. Now this is something that we have formalized. First, we are going to introduce the question. Secondly, we are going to reveal the answer. And thirdly, we're going to discuss how to get to the answer, or we might even find errors in the answer. So we are going to analyze the answer. Now let's get to question number 1. Give 2 reasons why a programmer may use hexadecimal to represent binary numbers. I would appreciate if you can try it yourself before we can jump to the answer. Now here is the answer for this question. We need to give 2 reasons why a programmer may prefer hexadecimal over binary numbers. Answer number 1, point number 1, hexadecimal takes less storage space than binary. It sounds true because, as we can see, a 16-digit binary can be represented by a 4-digit hexadecimal. So it really must take less storage space. Now let's look at this question. Let's find the errors, find the incorrect. Now what this question really asks is, we need to find incorrect answer. Find the incorrect answer. So from this 2 statement, which statement is incorrect? Is both incorrect? Is 1 out of the 2 incorrect? Now the incorrect statement, or the statement which has missing information, is statement number 1. Statement 1 is incorrect. And the reason for that is hexadecimal provides a shorter form of representation on screen, but in memory, all data is ultimately stored in binary form. So when we say hexadecimal takes less storage space than binary, it is incorrect because hexadecimal is ultimately stored in binary form. So the correct statement needs to be hexadecimal provides a shorter form of representation on screen. So when it comes to theory questions in paper 1, this might be one of the greatest tips in order to solve theory questions. Now I know that many of you have this perception that you need to memorize the mark scheme, but that is not exactly the case. Or what Cambridge really wants is CIE level accuracy. And this is something that your teacher needs to introduce you to the idea behind CIE accuracy. Now this is a term that I have coined after analyzing multiple past papers, that CIE wants accuracy in your answers. So these are the 3 points that you need to remember. What does CIE accuracy means? It means you need to include essential keywords related to the syllabus. So your answer must have essential keywords included in them. Now where do you find these keywords? You find them in the syllabus, or you learn them as you progress along your coursework, or your teachers helps you to learn these essential keywords. The second point is no missing clarification. Now this point is going to be elaborated in the question that we are going to attempt. Okay, the third statement is no generalized statements, which means no vague statement, no general statement. You need to give a super specific statement featuring the question's scenario. Let's jump to question number 2 from February-March 23. A new computer comes with a primary and secondary storage. Data storage is measured using binary denomination. Complete each conversion. The first conversion, let's see the answer. 8 bytes equals to 32 nibbles. We need to find the incorrect answer. Incorrect answers, let's see, because here we have 4 answers. So is the first option correct? Let's check. The main ask is that 8 bytes equal to how many nibbles? So 1 nibble is equal to 4 bits, and 1 byte is equal to 8 bits. So that gives us 1 byte is equal to 2 nibble, because 1 nibble is 4 bits, 8 bits make 2 nibble. So 1 byte equal to 2 nibble. So the usual unitary method, 1 byte equals to 2 nibble, 8 byte equals 2 times 8 equals 16 nibble. So 16 is going to be the answer, 32 is incorrect. Now let's check if the rest of the answers are correct or incorrect before we get to investigate the answer for part B, which is 512 kibibyte equal to how many megabyte. Let's learn how to calculate this in the first place. So the steps for unit conversion. Step number 1, we need to determine the unit value in bytes for each of the units. Step number 2, find the power difference in bytes. Step 3, make subject the larger unit. And step 4, implement unitary method. Now let's see this in practical. So step 1, determine the unit values in bytes. So 1 kibibyte. So in the question we need to convert from kibibyte to megabyte. So here goes the unit value in bytes for both of the units. So 1 kibibyte is equal to 2 raised to the power 10 bytes. 1 megabyte is equal to 2 raised to the power 20 bytes. So the power difference is by 10. Step 3, make subject the larger unit. So here the larger unit is megabyte. So 1 megabyte is equal to 2 to the power 20 bytes. Now from here we are going to expand the power in order to substitute the smaller power inside this expansion. So 1 megabyte is equal to 2 to the power 20 bytes. If we expand this, we get 2 to the power 10 times 2 to the power 10. Now 2 to the power 10 can be replaced by 1 kibibyte. So 1 kibibyte times 1024. And if we simplify it, we get 1 megabyte is equal to 1024 kibibyte. In the question, however, we were asked to find 512 kibibyte is equal to how many megabytes. So we need to reverse the units. So now we make kibibyte the subject, because now we make the kibibyte the subject. So 1000, so 1024 kibibyte is equal to 1 megabyte that we just got. Now the usual unitary method, 1 kibibyte is equal to 1 over 1024, and 512 kibibyte is equal to 512 over 1024, which gives us 0.5 megabyte. So the answer that we were given in part B, that 512 kibibyte is equal to 1024 megabyte, this is incorrect. The correct answer is 0.5 megabytes. So there we have it, answer number B. Answer number C and D is correct. Now these are for you guys to check and confirm if these two are correct or not. We will move on to question number 3. Let's move on to question number 3 from MJ24. The health value for a character in the computer game can sometimes be a negative value. The negative values are stored as 2's complement, 8-bit integers. A character has a health value of negative 25. Calculate the 2's complement 8-bit integer for negative 25. So 2's complement is basically a convention that is used to represent negative numbers in binary. We have a 3-step method to convert. We have a 3-step method that is used to represent a negative number in binary. So the 2's complement have got a 3-step method. Step number 1, convert the number into 8-bit binary. Let's do that at first. So let's convert the number into 8-bit binary. So 25 converted to binary. So we have 2 to the power 0 as 1. We have got 2, 4. These are the powers of 2. 8, 16, 32, 64, and 128. Now to create 25, the closest value that we need to switch on is 16. So we need 116 8. So 16 plus 8 is 24, and then we need a 1 to make 25. And the rest are switched off. This gives us 25 because 16 plus 8 plus 1 is equal to 25. So the binary representation, 8-bit binary representation is 0001 1001. The second step is flip all the 1 bits to 0 and all the 0 bits to 1. So let's flip 0 0 1. After flipping, we are going to get 1 1 1 0 0 1 1 0. Third and the last step, add 1 to the original number. That is going to give us 1 1 1 0 0 1 1 1. That is the answer. Now let's recheck to confirm if this is the right answer, if this represents negative 25. So there we go, we get negative 25. It's confirmed that this number represents negative 25 in 8 bits. From May-June 2025. From May-June 25. Now this question is about color depth. State what is meant by a color depth of 32 bits. State what is meant by a color depth of 32 bits. Now the more color depth is equal to more shades per color. Each bit is going to store one shade of that color. So state what is meant by a color depth of 32 bits. So I try to put in as many points as possible, covering the CIE accepted accuracy. 32 bits are used to represent a single color, providing 2 to the power 32 different shades of colors. The reason for 2 to the power 32 is because one bit allows two options. So one bit can store either 0 or 1. When we have 2-bit, so this 1 bit can have either 0 or 1. So when we have 2-bit, it could be 0 1, it can be 0 0, can be 0 1, can be 1 0, can be 1 1. So 4 total combinations. 4 combination. So when we have 32-bit, we get 2 to the power 32 combinations. Hence 2 to the power 32 different shades of colors. The color depth of the image file is changed to 64, so it is raised to 64 bits. Explain what effect this change has on the image file. The size of the image file is going to increase as there are more bits to represent a single color. Question number 5, lossless compression. Describe how lossless compression compresses the text file. Describe how lossless compression compresses the file. The file size is reduced by identifying repeated words and pattern. So the repeated word is the keyword here, which the CIE accuracy is looking for. The second point, the file is then represented as a shortened code using a RLA algorithm. So here we get 2 points at once. The third point is the file is finally brought back to original when required. Question number 6 from Winter 24. It is a question about file size calculation. A 10-second sound effect is recorded for a movie. It is recorded with a sample rate of 22,016 Hz and a sample resolution of 8 bits. Calculate the file size of the sound effect in KB byte, and we need to show all our working. Let's recall the formula. The formula to find the sound, the formula to find the file size is sample rate in hertz. It's multiplied by sample resolution in bits multiplied by the length of the sound file in seconds. Now let's plug in the values. So currently we are calculating in bits, so this is going to give us, so this is 8-bit. Let's convert this. Let's rearrange. Times 8-bit is equal to 1 byte times 10. So now we are going to get our answer in byte. 0 byte. Now let's convert byte into KB byte. So what we know is 1024 bytes is equal to 1 KB byte, because 1 KB byte is 2 to the power 10 bytes. So 1 byte is equal to 1 over 1024, 215 KB byte. That is your answer over there. So this is the part that you need to be careful. From 8-bit, I converted 8-bit to 1 byte because these are the same. I just substituted 8 bits with 1 byte. So I did the conversion early on, which made it easier for me. So Nancy uses her camera to capture image of her holiday. The captured images are stored as digital photo files on her camera. Explain how the captured image are converted to digital photo files. So basically how image is converted to digital, or image is converted to binary. Each captured image is made up of pixels. Point number 2. Each pixel is made up of a color. Now the last question is the draw question, and the purpose behind draw question is to help candidates visualize, not just memorize, but to visualize theoretical answers. So the third subtopic of chapter 1 is data storage, and in here we have a part. Okay, the question is draw an annotated diagram to represent the process of RLE compression. This has not appeared before. This has not appeared ever in past paper questions. So I've made this question up. What is the process which are going to enable us draw any diagram question? How can we really convert theory into visual diagrams? So after the introduction of draw questions from 2023 onwards, the approach for paper 1 needs to be different. Currently, CIE can ask a draw question from any part of the any part of the theory syllabus. So all theory needs to be understood visually. Introduction of these draw questions, the approach for paper 1 needs to be different. CIE can now ask a draw question from any part of the theory syllabus. So any part from the paper 1, a draw question can be derived. So all theory needs to be understood visually. So in order to draw the RLE compression, here I have a theory answer. In RLE, repeated pattern in an image or text is identified and grouped into 2 values. From here we can understand is that we can choose either image or text. So in our diagram we are going to represent a string of text that is converted, that is going to be grouped into 2 values, that is going to be converted into 2 values only. The first encoded value out of the 2 represents the number of repetition, and the second encoded value represents unique code of the data. The third point is this short representation can be restored back to its original state. So these are our hints to draw the diagram. So at first let's draw a string a string of text. So let's represent our text, because that is what we have now for the first part. So let's say we have a string of a, repeated a, and this is going to be represented by, this is going to be grouped into two values. The first value is the number of repetition, and the second value is the unique code of this data. So these are our objects. A text is an object that is represented by the repeated string of a. Grouping two value is an object that is represented by the right hand side. So these are the two objects. Now we need to use arrows to connect them. The third point says the shorter representation can be restored back to its original. So let's draw arrows that is going to indicate that this can be restored back. So for the annotation part, we're going to take help from the original answer, because the answer is what we have memorized. The theory answer is at our disposal, but this needs to be redesigned in a way that is going to give us small hints about what the diagram would really look like. So from here we are going to extract the annotation. Let's select that repeated pattern in the text is identified. So repeated pattern in the text is identified. The first encoded value is the number of repetition. The second encoded value is the ASCII. So number 3, the shorter representation can be restored to its original state. There we go. This is the diagram for run length encoding. With that, we are going to end our session for selected chapter-wise question from chapter 1.